This video provides an overview of Kornucopia ML's tools for quickly and accurately analyzing noisy data. Kornucopia ML for use with Matlab is truly the horn of plenty, with a large number of tools to help you analyze real-world complex data. These tools are applicable for both physical test data and simulation results. In this video, we will concentrate on the DSP tools for filtering and spectrum analysis, as well as the shock response tools to allow you to compute an absolute acceleration or pseudo-velocity shock spectra. All the features in Kornucopia ML's tool suite are based on a new data type called K_units, which we will briefly describe next. This new data type, inspired by Matlab's table data type, allows you to hold an array of numeric data, its units, descriptive text, and other related meta information in a single container-like variable. This is coupled to a seamless units engine provided by Kornucopia, which ultimately allows for cleaner Matlab scripts with less mistakes. Here's a typical data variable being presented with the Kornucopia variable viewer. As you can see, there's some additional descriptive information at the top, column names and units, and a large set of tabular data. Here's an example of a typical kind of calculation that can be done in Kornucopia. The key points are we have an organized tabular data format. Equations and commands are easy to read. Kornucopia handles all the units-related portions of the calculations, including the use of mixed units. These calculations work very efficiently with very large data sets, and your analysis is clear and accurate. Kornucopia ML has a very powerful yet easy-to-use set of tools for analyzing noisy data. There are functions to assess sampling rate, and if it is irregular, to regularize it, as well as to change the sampling rate through decimation or upsampling. There are functions to compute a discrete Fourier series and power spectral density to analyze spectral content, and a variety of functions to easily create and apply IIR and FIR filters in either low-pass, high-pass, band-stop, or bandpass forms. The K_smooth function is a very popular tool that provides a simplified way to smooth data using just a single smoothing factor. Internally, the function uses the 6th-order bidirectional low-pass Butterworth filter with Kornucopia's advanced end effect minimization technology. And lastly, we have functions to allow you to assess shock severity via the shock response spectra methods. In addition to the shock response spectra functions, we also have functions to allow you to create and study pulses. Kornucopia ML provides high-level functionality in Matlab. Here's an example of computing a discrete Fourier series, what many people would call the FFT. Following the instructions in Matlab's help, these are the commands you would type to compute a DFS in Matlab. In Kornucopia ML, you would just use these few functions, one to compute the discrete Fourier series and one to plot it. An additional benefit is that Kornucopia checks the sampling rate of the data to ensure it is constant. If it is not, an error message will tell you what to do, including how to fix it with Kornucopia's regularization function. Here's a typical analysis of transient data in Kornucopia, where we're utilizing both a discrete Fourier series and applying filtering. Depicted is a figure window showing not only the input data, but the various important plots of the calculation. First, the data would have been regularized, and then the discrete Fourier series was computed with the function shown here. Then these three commands would compute the sample rate, define the cutoff frequency, and compute the filter coefficients. And lastly, the filter would be applied to the data, where the last command adds an additional description, which is shown as the title on the plot. The key points are that the commands are easy to use and read. Kornucopia handles all units-related portions of the calculations, and Kornucopia's plotting functionality makes it fast and easy to create highly informative summary figures. Kornucopia provides robust technology for the unique challenges with explicit dynamics data. Processing this type of simulation data requires special algorithms that most software offering DSP features do not include. Issues that must be addressed are constantly changing time increments, massively oversampled data, relatively short signals, and filter-induced end effect distortions, as well as other filter-induced distortions. Kornucopia has specially designed DSP technology to address all of these issues, and the same DSP technology works well with physical test data too. Along with robust software, proper training is encouraged. With our training, you can learn how to safely output data and avoid aliasing. We provide you with a complete strategy ranging from outputting the data to analyzing it. This strategy is applicable to both transient dynamic simulations as well as quasi-static problems solved via these methods. With our training, you will understand how to apply filtering with confidence. Utilizing the right DSP tool is important. Here's a simulation result of a sliding contact problem analyzed with an explicit method where the same model is being post-processed by 5 different analysts, and they are asked what is the maximum load at the end of the simulation. As you see in the table, 4 of the 5 analysts get a very similar result, where Bob's result is almost 2x larger. If we look at the actual simulation data, we see that the pack somehow has predicted a result that doesn't even go through the data, yet Bob's result appears to be quite accurate. Maybe we should hire Bob. These are the actual simulation results predicted by the various analysts. One of the key things you see is that given the same FEA data, wildly different results can occur when various software and filters are applied. The poor results from the pack are due to issues such as filter-induced end effect distortions and time delays, all of which commonly appear in results processed using traditional DSP tools. Bob's accurate results come from his use of Kornucopia ML, where such undesirable issues are mitigated by Kornucopia's advanced DSP algorithms. Kornucopia also makes it quite easy to clean, messy, and noisy data in a very controllable manner. Here is some stress-strain data to be used for material characterization. This data would commonly come from physical tests that are being pushed to their limit, or maybe an analysis result from an explicit dynamics model. In either case, the need is to clean the data to create a credible stress-strain curve without the oscillations. Here's a Matlab session showing the data being cleaned via Kornucopia's K_smooth functionality using a simple smoothing factor. Behind the scenes, this function is using Kornucopia's low-pass filtering tools, but via K_smooth, it is all packaged in a way that makes it easy to use. With this approach, the user has quickly cleaned their data, creating a credible representation of the material stress-strain response. Next, we show an example of Kornucopia ML analyzing shock data. Here's a typical acceleration response of a measured environment, where the data is stored in an orderly Kornucopia table. With simple commands like this, we can convert the acceleration versus time to a computed transient velocity. The key points are we're using well-labeled data via K_units data type. Integration was easy, and Kornucopia handled all the units and provided clearly labeled plots. Next, we show computing and plotting the shock response. The equations on the right define a few parameters and then compute the absolute acceleration and pseudo-velocity shock spectra. And these commands produce the plots as shown on the left. The key points in this workflow is that the shock response was easily computed for multiple forms. Kornucopia handled all the units, and plotting via the K_plot functionality allowed us to easily compute a 4CP plot, and of course all the plots were automatically labeled. Working with noisy data can be quite challenging, and proper training is extremely beneficial. Bodhi Technology offers the following customizable 4-day training course to meet these needs. Taught in the language of mechanical engineering, the course mixes lectures and workshops to provide attendees with a solid foundation of DSP fundamentals, incorporated with practical and pragmatic strategies for applying this technology to both physical test data as well as simulation results. With our training, you will learn to analyze noisy data with confidence. With Kornucopia ML, you get faster data analysis with greater understanding, because you get to work with all your data, numbers, units, and text. This enables flexible and more accurate workflows, giving you and your team greater confidence in your results. There are tools to process messy and noisy data for solving important, real-world problems. With efficient plotting that has automatic labeling, you can quickly and clearly communicate your results. And our real-world template examples allow you to jumpstart your solutions. This is all supported with a teaching help system that allows you to learn more and grow your value. Kornucopia ML improves the speed, precision, and effectiveness of you and your team.